So number 2, so we know that angle 2 and angle 3 are congruent. That's given to us. I'm going to go ahead and put it as a measure. Measures are more useful. You're going to find that when I give you something congruent, you're automatically going to turn it to a measure because that's what a lot of things are, where you can do the segment addition postulate, you can do the angle addition postulate. So I just see that, turn it to a measure. And that is just our definition of congruence. Then I throw in the other one. Now, I want to note that linear pair is a special word. It doesn't mean you're always going to go to the definition. I just said most of the time. What I'm going to do is I'm going to look at what the next step says. It says specifically supplementary. Linear pair shows up in 3 places. It'll show up in your definitions, it'll show up in a postulate, and it'll show up in your theorem. You need to find the one that specifically says supplementary. It has to say the word supplementary in it. So if you go through your packet and find all the different places that has supplementary in it, the only one that says linear pair is the theorem. That's the only place that says supplementary. And if you don't believe me, you should probably have your packets out right now and looking through that stuff. You should have your packet out. If you're not sure what I'm talking about, you should be in your theorems right now, looking up your linear pair theorem and make sure it says supplementary. The people that do well on this test are going to be people that know how to use this packet and know where things are and know what they say. You should be practicing just reading your packet, just finding this stuff. Because if you know the theorem says supplementary, this one's real easy. So the theorem says supplementary. Supplementary then needs to turn to 180 degrees. Well, that's the definition of supplementary. So if I use the definition of supplementary, I can say that means angle 1 plus angle 2 equals 180 degrees by definition of supplementary. Well, then if we look at this next step, I want to have angle 1 and angle 3 supplementary. So I need to talk about angle 1 and 3. So what I did is I used substitution to take the fact that measure of angle 2 equals measure of angle 3. Pop, pop, pop. Bam. Plugged in that place, that's substitution. And then I just have to go, oh, if they equal 180, I can use the definition of supplementary. Once again, we need to look up definitions. And that means that angle 1 and angle 3 are supplementary by the definition of supplementary angles. Linear pair is really the only one that you don't really look up the definition for. That one you look at your postulate or your theorems. Everything else you basically look in your definitions. It's just linear pair that kind of stands out to me as something that's different. Do all those steps make sense? Cool. Yeah.
Can we do number 4?
Sure. Is 4 the one? 5. Okay, I was like, we just did 4, right? 5.
I was thinking where they were both like empty.
I gotcha. Let's go through it. I bet you got the first step though, right? Given. All right. So we are given their supplementary. What do we do if I hear the word supplementary? What's usually my next step? Unpack it, which means definition. Definition says it equals 180. So my next step is this equals 180. This equals 180. Definition of supplementary. Now we can go ahead and say that these two things are equal to each other. I use the transitive property. We probably could have used substitution as well, because what I'm saying is, you know what? Measure of angle 1 plus measure of angle 2 equals 180. 180 links us to measure of angle 1 plus measure of angle 2. That's a transitive property. It's a train. I created a train to get from here all the way there. I got my equal sign. Transitive. Now, this is the weird thing. You can subtract measure of angle 1 from both sides. So I can straight up go, well, minus measure of angle 1, minus measure of angle 1, and I'm left with measure of angle 2 equals measure of angle 3. But we do have to prove it's congruent, so I change the sign from equal to congruent. That's the definition of congruence. For those of you that didn't do your homework, it's not helping you if you just copy this. If you had questions on it, copy it. But if you haven't done your homework, try it on your own first. Because it's way more important for you to try it first and then figure out where you're stuck and ask questions and finish it that way. Other questions on this one in particular? If we have more questions and we have time, I'll be more than happy to answer more of them. But I do want to get through today's lesson really quick so we don't shortchange anyone. Hopefully we can get through it so we can have some questions. I just want to make sure we can get through. All right. So today's lesson is just 3 proofs. Just 3 proofs we have to get through. Hopefully it's not too bad. I know proofs can be difficult because you're kind of just sitting there passively watching me. My advice to you is be active in this. Volunteer answers. Look everything up as I'm doing it. Try to figure out if you know how to do the next step. Don't just wait for me to do it. Figure out the next step on your own. You don't have to write it. Just start thinking of the next step. Now, I know the first thing I want to do is I want to say the given. So I want to say 1, angle 1 and angle 2 form a linear pair. That is given. I'm going to skip the second given for right now. I have angle 1 equals angle 2. That's cool, or congruent. Let's hold on to that for a second because I see a fancy word, linear pair. Now, normally when I say unpack a word, I mean look at the definitions, right? That's what I typically mean. Linear pair is the rare exception. Linear pair, I'm usually looking for a postulate or a theorem. And if you look at the postulate or theorem, either one of them will work here. You can use the postulate to say they equal 180, or you can use the theorem to say they're supplementary. Just for class purposes, we're going to use the theorem. We're going to use the theorem. So I'm going to unpack that word by using the linear pair theorem. I picked the theorem. Can you raise your hand and tell me, does that mean it's supplementary or it's equal to 180? And if you're not sure, look it up. Elmer? It means supplementary. So I have to use the word supplementary. So my second step is going to be measure of angle 1 plus measure... Nope, stop that. Angle 1 and angle 2 are supplementary. I'm going to tell you right now, I picked the wrong one. I picked it on purpose. Because there is no picking the wrong one for the linear pair, unless I give you the reason off to the side. Why I'm saying I picked the wrong one is, what does it mean to be perpendicular? They form 90-degree angles. So if I look at what I need to prove that there's 90-degree angles. Does supplementary have any degrees in it right now? No, I probably wanted 180 degrees because 180 degrees, I might be able to back off and back it to 90 degrees. So right now I'm like, I should have said something about 180 degrees. I wrote this in pen. I'm going to move forward. I'm going to say, I should have probably picked the postulate. The postulate says they equal 180. Probably would have been a quicker way to do this. But it's totally fine to go, well, I know what supplementary means. Supplementary means the two angles equal what? 180 degrees. So I go, okay, I picked the wrong. Do you understand why I kind of picked the wrong one here? But it's okay because I can move forward. I can say, you know what? I can still say measure of angle 1 plus measure of angle 2 equals 180 degrees because that's the definition of supplementary. So we now have it equaling 180 degrees. Cool. Cool beans. I went from a linear pair to actually having 180 degrees. I'm moving. I'm chugging along. Now I'm going to go, done with linear pair. I can't break it apart any further. So now I look back up. Is there another given? Yes. I have angle 1 is congruent to angle 2. That is given to me as well. I don't like congruent symbols. They don't work with adding and subtracting. How do I get rid of the congruent symbol? Yeah, Ty. Definition of congruency. And then we'll turn off my screen real quick, just for funsies. No! You actually logged me out? Iron. You can do this. Let's see if this pops back up. Yeah, we're back in action. All right. So, Ty said we're going to use the definition of congruence. I'm just going to put the congruent symbol. That means I can switch from a congruent symbol to an equal symbol. Be careful when you do this because I have to tack on measures. I have to put measure of angle 1 equals measure of angle 2. All right, so remember my goal is to create either 1 equals 90 degrees or 2 equals 90 degrees. Either one of them, I could prove either one of them equals 90 degrees and I'm done. It's perpendicular. If you look at the definition of perpendicular, it just needs one angle, needs to be 90 degrees and it's perpendicular. So what I'm looking at right here is I'm going to get rid of this 2 right here. I want to turn that 2 into an angle 1. Is that possible right now? Is it possible for me to get rid of that measure of angle 2 and put measure of angle 1 in its place? Are those two things equal?
Yes.
Yeah, so yes, we can replace it. I'm going to use substitution. Here's a good rule of thumb for substitution. See, I'm substituting in for just a part. That's a good rule of thumb that you can't use transitive. You're going to use substitution. I'm not replacing an entire side. It's just a part of the equation. We're going to use substitution. So I'm going to go ahead and use substitution and say, well, that means measure of angle 1 plus measure of angle 1 equals 180 degrees. Now, what I want to notice is that trick right there, I got rid of angle 2. I'm now just talking about angle 1. And all I used was substitution. Whew. It feels like it's a lot of steps, but it's a lot of little steps. Yeah.
Oh wait, never mind. I just wanted to explain.
Go. What do I do next?
Subtract measure angle 1 from both sides.
It'd be cool if I could. We could. I get what you're going there. Our idea is that if I can subtract angle 1 from both sides. But did I ever say angle 1 equals 90? So I can't subtract from. I have to subtract the same thing from both sides. I like your thought process, though. What if this was x plus x equals 180?
Well, wait, it would be 2x equals 180.
Yeah, Owen.
I thought we would know it's 90 if angle 1 and angle 2 are equal to each other.
We do, but we have to say, we all know it's true, but we have to say step by step why it's true. You're basically explaining to someone that doesn't know math why. You can't just say, because I know it does.
Yeah.
You can't use that. So what did you say? If it was x plus x equals 180, how do I solve for x? It'd be 2x. Well, we could do the same thing. We can do 2 times the measure of angle 1. I have 2 of those. Equals 180. I'm going to say collect like terms. But as a reminder, you could just put simplify. Simplify I'd be okay with. But collect like terms looks a little better. A little more algebraic. Yeah. Yeah, what do we do next? Go. We're going to divide by 2. I'm just going to divide both sides by 2, just like solving for x. Are you okay?
Yeah.
You sure?
1 divided by 2.
Say that again?
1 divided by 2. Oh, never mind.
Oh, yeah, we're dividing that 2 by, not angle 1 by 2, but it's basically 2x equals, we have to remember that these are just variables. They're placeholders. These are basically x plus y equals 180. Oh, x plus x equals 180. Now I have 2x equals 180, which means I have x, which is our measure of angle 1, equals 90. Yep, division property of equality. Perfect.
Could you go over number 7 again?
Yeah, hold on just one second. I'm going to finish this. Are we done?
Can you just look at it and be like, yeah, that's 90?
Just add them both together.
Yeah, because there's 2 of them. It's just like if this was x plus x, what would you do? I would add them and have 2 x's. It's the same thing. These are just variables.
Collect like means
Collect like terms means add them. Yep. I also said you could just say simplify. I added them. You could put I added them. I really don't care about that. In a lot of geometry curriculums, they say completely different things, so I'm kind of accepting anything I've seen in a geometry class. Okay. Now, here is the semantics of this. Can someone read me the definition of perpendicular? Yeah, Savar.
2 lines that intersect to form a right or 90 degree.
That form a 90-degree angle, right? Do we have an angle forming a 90-degree angle? Yes. So can't we use the definition now? Yeah. So we can now go, number 9, that must mean that AB, we just need one angle. We just need one of those angles to be 90 degrees, and we have a perpendicular. And that's definition of perpendicular. Questions on any of that? Questions going once, going twice. Sie sold then. Now, I don't expect you to know how to do this proof. Some of you might be at the stage where you're like, I get kind of the steps that are going on. But after I explain them, do all those steps at least make sense in the logical progression of things? I don't want you to get bogged down with the fact that it's 9 steps. There are 9 logical steps. They just kind of follow each other. Notice how proofs kind of just follow what happened above. I kind of picture them as dominoes. And that's where we get the law of syllogism, that it just has to connect to what happened before it. All right, let's go through this one. This one's a really cool one. So I have angle 2. I have angle 2 is supplementary to angle 3. I have angle 1 is supplementary to angle 4. Now remember, we're focusing on 2 theorems right now. We're focusing on the linear pair theorem, and we're focusing on vertical angles. What do we immediately see about this picture? Oliver?
I was going to say given, but... sure.
Yeah. What do we immediately notice about this picture? Matt?
Congruent?
They're congruent. 3 and 4 are congruent because they are vertical angle. They're vertical angles. We can use the vertical angle theorem. So as soon as I saw that picture, in my mind, I'm like, vertical angles, they're congruent. I bet you anybody that's somewhere in this proof, they'll say 3 equals 4 because of the vertical angle theorem. You should already know that. Now, why that's important to you is because some of us just won't be great proof writers. It's just the way of it. It just happens sometimes. But you know what? Those people can still get a lot of points by putting facts down that make sense, like vertical angle theorem. That's how you start getting little points, even if you're not sure how the proof works. I love the idea. Let's go for our given, right? So our given says angle 1 is supplementary to angle 2. Now, without looking at what I'm supposed to prove, how do I already know the next step? I already know the next step. I don't even know what I need to prove. I know what I should do next. Yes?
It says supplementary.
It says supplementary. What does that mean to you?
Equals 180.
It equals 180. It means definition. Unpack definition 180. So I'm going to say let's unpack both of those. Let me see how much room I gave for these. I just don't want to impede on the next one. So I did give us room for both of these. So I'm going to put both of these on step 2, but I'm going to use both boxes. I'm going to say, well, that means measure of angle 2 plus measure of angle 3 equals 180. I'm going to skip to the next box because we do have room. I'll put measure of angle 1 plus measure of angle 4 equals 180. And here's the cool thing. I didn't write given. That's not the cool thing. I'll write it down here. The cool thing is I can just put this once. That's definition of supplementary. You can either just put step 2 and put both of them on step 2, or you can write a step 3 and just rewrite that thing. I like this. This makes sense to me. You're using the exact same thing, so I'm going to put them all as step 2. Okay, so I have angle 2 is so I have measure of angle 2 plus measure of angle 3 equals 180. I have measure of angle 1 plus measure of angle 4 equals 180. Do we have any more givens? No. So what I'm looking at now is I'm looking at, okay, 2 goes to 3, 1 goes to 4. What do we know about 3 and 4? They're congruent. Now, be careful. Vertical angle says they're congruent, correct? Can you read that for me? Does that theorem say congruent or equal? Are we sure it says congruent? Okay. Yes. Yes. Why I'm pointing that out is congruent means I have to say angle 3 is congruent to angle 4. That is the vertical angle theorem. Now, here's the thing. Am I going to lose my mind if you put measure of angle 3 equals measure of angle 4 and you kind of skip that little step? I will not lose my mind. This is just to make a better proof. Good proof would say measure of angle 3 equals measure of angle 4. A better proof uses the congruent symbol. A better proof now uses the next step to say that measure of angle 3 equals measure of angle 4. That is going to be our definition of congruence. Now, a lot of you out there aren't going to do that. You're going to put the measures. That's not going to kill you. It's just kind of the difference between like a 9.5 out of 10 and a 10 out of 10. It's just a small little smidgen. So if you're just like, I'll never remember that, it won't be the end of the world. Try to remember it, but it won't be the end of the world if you don't remember that. So vertical angle theorem says congruent. I need to turn congruent into an equal sign. Definition of congruence. Yep. Okay, so we have all that done. We have our definition of congruence. Now, what I want to point out here is I'm going to start writing an equation for us. I want measure of angle 1 equals measure of angle 2. So I want measure of angle 1 on one side. I want measure of angle 2 on the other side. So I'm looking back at this statement here. That equals 180. 180 equals 180. That equals that. They're all linked together by using what property? What property lets me go this equals this equals this, and that equals that? Transitive property. So by the transitive property, I can now write an equation. I can write an equation that says something like measure of angle 1 plus measure of angle 4 equals measure of angle 2 plus measure of angle 3.
So transitives like the syllogism.
Yeah, it's perfect. Perfect explanation of that. That is our syllogism. That is our transitive property. Oh, can you guys do me a quick favor? I don't know why. My type is not working on these. And now my last step is I'm going to subtract measure of angle 3 from both sides. Those guys are going to get subtracted, and I'll be left with measure of angle 1. That's actually step 7. 7, measure of angle 1 equals measure of angle 2, and that's our subtraction property of equality. Oh, I thought you had a question. I want to point something out to you. If you actually did what I said, where you just dive into that packet, you just looked up at stuff that we haven't really talked about in class, you'd realize there's actually a theorem that actually is a shortcut for this one. What I'd like you to do is find a theorem that says something about if an angle is supplementary to, if two angles are supplementary to another angle, that either the same or equivalent angles, that the original ones were equal to each other. Can anyone find that? Xavier? The congruent supplement theorem. The congruent supplement theorem could have been used right here and we'd be done. Because we said one angle is supplementary to 3, 1's equal to 4, 3 and 4 are equal to each other, so we could have used that property there. I don't typically use that property a lot. It's just on you whether you can use it or not. It shortens proofs. It really is for people that dive into those theorem packets and try things. So it's for people that really want to understand this stuff. If you don't, if you just want to passively sit there and do this and don't go into that stuff, then you're going to have to go the long way through this, which is fine. But if you're ambitious and you read through all that stuff on your own and practice, you will find shortcuts in the proofs I do. That will be little nuggets for people that actually kind of study your packet every night and look over stuff. That's crazy stuff happening everywhere. Were those your earbuds too? All right, the last thing I want to talk about. So we talked about the linear pair theorem. We talked about vertical angle theorem. Now let's talk about turning things into algebraic expressions. We've already been doing this, but I'm going to focus on it on this one. The first given says B is the, or is a, I'm going to change it to the midpoint of AC. That is my given. I need to do two things immediately. Can someone tell me one thing I should do next? Yeah. Put our tick marks. That's the easier thing. What's the next thing I have to do? Yes.
Define midpoint.
I have to define midpoint. So that'll be my second step is definition of midpoint. Now I'm going to ask you guys, raise your hand. What am I going to write for my statement if I'm using the definition of midpoint? I'm using definition of midpoint. What's the statement? You want to follow it up too? Yeah.
AB equals BC.
Perfect. AB equals BC. The definition of midpoint is it creates two. We should be able to do this. I should be able to give you a midpoint and you immediately go, oh, that's two congruent segments. Oh,
Should you put a congruent sign over it?
I would not. The only time I put a congruent sign is if I put lines above it.
I would.
And the midpoint says it creates two equal segments.
Equal and congruent don't mean the same thing.
They do, but they mean slightly different. One says to put an equal sign, one says to put a congruent sign. Okay? It's all kind of semantics too. I don't really take off a ton of points for putting the... If you would have put a congruent symbol, you would have to change it to an equal symbol though. Because we're going to set up an equation. Because our job is to turn this into algebraic expressions. I don't think algebraic expressions have congruent symbols in them. They have equal symbols. Equal symbols are better than congruent symbols when we're proving stuff. The only time I'm going to go to congruent is at the very end if I have to. Okay, so now we have AB equals BC. Now, let's look what we have to prove. I have to prove that AB equals 1/2 of AC. Does that make sense?
Nope.
That AB is half the size of this entire length?
Yes.
Doesn't it have to be if both of these are equal to each other? Okay, so we need to create an equation that says, well, segment plus segment equals a bigger segment. What allows us to say that? Segment plus a segment equals a bigger segment. Yeah.
Segment addition box.
So my next reason is segment addition postulate. I know you're not asleep, but can you pick up your head? Can someone else raise your hand and tell me what that means I can write on the left-hand side? Yeah.
AB plus BC equals AC.
Yes, perfect. AB plus BC equals AC. Do we notice how this equation just has AB and AC in it, doesn't have a BC? Can someone raise your hand and tell me how we're going to get rid of this BC? That's really all we need to do. I need to get rid of this BC. Everything is failing me today. Alejandro. We can use the, I'm going to change that to substitution. We don't have 3 steps. We just have AB equals BC. Now I can plug it in there. I need that third step to use transitive. Does that, it kind of make, so here's the way I think about it. Do you notice how we're just replacing part of the equation? That's typically going to be substitution. Okay, that's a good sign to me that I'm using substitution. Okay, so our fourth step is going to be substitution. I'm going to have AB plus AB equals AC. And substitution is the only thing that works there. Okay, can someone raise your hand and tell me what my next step is going to be? Yeah.
2AB.
2AB. How do we do that? What are some things that let us do? Yeah. Name one way we can
Distributed.
we can put the distributive property. We can put simplify. We could put collect like terms. I'm going to put collect like terms. But no, any one of those would have worked for me. Step 6. Who's got step 6? I want all of it. I want the statement and I want the reason why. Statement and the reason why. Give everyone a chance. Maybe it could be someone new that hasn't given me an answer yet. I'll wait. If you're going to grab one, this is the one to grab because we've done this. That's it. We just have 3 people that want to answer this one. 4. I don't think Julian's answered a lot. Yeah. We're going to use the division property of equality because we're going to divide both sides by 2. That'll give me AB equals AC over 2, which is really 1/2 AC. That is our division property of equality. Do these feel at least a little easier today? Like you can start seeing the pattern. It's not just copying my stuff. That's how we want it to be. Now, I don't want to scare you for the test. I'm not going to pick super hard proofs. There's not going to be most of them will be kind of scaffold proofs like we're doing. We are going to pick one that's just going to be kind of blank. That is both sides we got to fill in. I'll try to pick one that's pretty easy. At least people that don't understand proofs can pick out key things like, hey, those are vertical angles. Mr. Pabian, I know 3 and 4 are equal to each other. Or I'll pick, this is a midpoint, so you can say, oh, by definition, a midpoint. Like things we can put stuff down even if we're not the strongest at proofs.